Properties of parallelograms. You guys learned parallelograms back in elementary school, yes? At least what they were. Maybe not all the properties, but you at least learned what they were. Yes? Okay. First property is more of a definition, but it's still something we can use. Opposite sides are what? Definition of parallelogram. Opposite sides are not just equal, but are parallel. Okay. I'm going to put a little note here that this is the definition of a parallelogram. Shorthand for parallelogram, so we're not writing it every single time, is just like we use the image of a triangle for the word triangle. We use the image of a parallelogram instead of writing out parallelogram. So when you see that, it just means parallelogram. All right, so we're just going to draw a quick image of this, of what we just described. Here's a parallelogram. Opposite sides are parallel. Why can't I just use one arrow on each side? Because they're not all parallel to each other. This set is parallel and this set is parallel. Make sense? Okay, number 2. This is a property. Opposite sides are congruent. And what you're going to be doing today is using these properties for x, or solve for y, or z, whatever variables you may have. Opposite sides are congruent. What does that mean? I'm going to put tick marks here. Okay, so if I have a parallelogram, if they say this is a parallelogram, then automatically opposite sides are congruent. And we can use that to help us solve for our variables. Number 3, opposite angles are congruent. Not only are opposite sides congruent, but opposite angles are also congruent. What does that mean? Let's draw our picture down. Okay, this angle and this one here are considered opposite angles. Angle congruent to its opposite angle. Is there another set of opposite angles in this picture? Yes? This corner with this corner. I marked them incorrectly. Why? That means they're all congruent, which they could be, but that's a special shape which we're not dealing with yet today. They're not all congruent to each other, so opposite. These two are congruent, and these two are congruent. They could all be congruent to each other. Again, that's a special parallelogram, which we'll deal with another day. Anybody know what type of parallelogram that is, if all angles are the same? No? It's okay. We'll get to it. Okay, number 4. Okay, this one's a bit much to take in, so we want to make sure we're all ready, we're all listening, because all of these were easy. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent. Now this one is consecutive angles are supplementary. Consecutive angles are supplementary. Okay, do we know what supplementary means? Adds up to what? 180. What does consecutive mean? Anybody know? One after another. When you guys hear the word consecutive, not in math, just the word in general, consecutive. He said like one after another in order. Yes? Okay, I'm going to number these angles so that we can talk about them. 1, 2, 3, 4. Okay, we used the word opposite earlier. What is 4's opposite angle? 2. What is 3's opposite angle? 1. Do you guys see that? Yes or no? Okay, now we're talking about consecutive next to an order. So 4 has 2 consecutive angles. 2 is not one of them. 2 is not angle 4's consecutive. 2 is angle 4's opposite. What is one of angle 4's consecutive? 1. And what is the other one? 3. They share a side. Do you see that? 4 and 3 share a side. 4 and 1 share a side. Do 4 and 2 share a side? No. So consecutive angles share a side. So what about angle 2? 2 shares a side with 1 and 3. Do you guys see that? Okay. What makes them supplemental? Let's think back to same side. I'm going to draw a quick picture over here. When lines are parallel, cut by a transversal. Do you guys remember that? What did we know about same side interior angles? These guys right here. They weren't equal. Remember the C shape? They weren't equal. What did they do? They added up to 180. There is a C shape here. Can you see that these are parallel, which makes this C, which means that these two add up to 180? A backward C, which means these two add up to 180. Are these lines parallel as well? Yes. Which makes an upward down C, or a C laying on its side. Do you see that? These two are congruent, and a downward facing C means 1 and 2 are not congruent. I'm sorry, I'm using the wrong word. What word should I be using? Supplementary. So 4 and 3 are supplementary, and 1 and 2 are supplementary. Got it? All right, so let's just write that down so we have it and we're able to use it. Angle 1 plus angle 1 plus angle what? Angle 1 plus angle 4 equals 180. Now, angle 1 plus another angle also equals 1 plus 4 and 1 plus 2. Does everybody agree with that? 1 plus 4 and 1 plus 2. Yes or no? Okay, what about 2? Angle 2 plus, I already did 2 plus 1, so 2 plus 3 equals 180. 2 and 1, 2 and 3. There's a 2 and 1, there's a 2 and 3. What about 3? Is it 3 with 1? Am I matching it up the right way? No. Angle 3 and angle 2, which I've already done, and 3 and angle what? 4. All right, now I'm at the 4. 4 and 3 and 4 and 1. Do I have both of those already? 4 and 3 and 4 and 1. Are they already taken care of? All right, so there's multiple ways of looking at it. Consecutive angles are supplementary. All right, number 5. Diagonals bisect each other. Diagonals bisect each other. When I have any parallelogram and I draw the diagonals, diagonals go from one angle to its opposite angle, like this. That's a diagonal. From one angle to its opposite angle, that is a diagonal. They bisect each other. What does it mean to bisect? In two equal pieces? Okay, so when I draw my diagonals, this one cuts this one in half, so those two are congruent. Now this one cuts this one in half, meaning these two are also congruent. I marked them incorrectly. Why? How? Where did I mess up? They're not all congruent to each other, not all the way around. So these two and these two, so I need double markings there. These two are congruent to each other. these two are congruent to each other. There is a special place, a special parallelogram where they all are equal. We'll deal with that later in the week. For now, these two are equal, those two are equal, not all equal to each other unless specified. Questions? Okay, this last one, it's not so much a property as something we're going to use to prove. This last one, I'm putting it in a bubble because it's not so much a property. It's just, okay, let me come back here. If I can prove opposite sides are parallel, it's a parallelogram. If I can prove opposite sides are congruent, it's a parallelogram. If I can prove opposite angles are congruent, it's a what? A what? It's a parallelogram. If I can prove that consecutive angles are supplementary, again, it's a parallelogram. And the last one, if I can prove that these guys bisect, the diagonals bisect each other, what's the name of the shape? Parallelogram. Okay, so this last one is, if you can prove this, it is a parallelogram. So it's not so much a property as it is, if you can prove it, it is a parallelogram. Okay, you ready? If you can prove that just one set of opposite sides is parallel and congruent at the same time, now it doesn't have to be these two, it could be these two over here, as long as it's one set of opposite sides that are parallel and congruent, one set of opposite sides are parallel and what? Congruent at the same time, then it is a what shape? If one set of opposite sides are parallel and congruent, then it is a parallelogram. All right, and we are going to use that today. Again, it's not a property, it's a, if you can prove. If you can prove that one set of opposite sides is both parallel and congruent at the same time, then the whole thing is a parallelogram. Questions?